Whoops. Oh, so cheap. I shouldn't have moved it. Don't move. Don't. Okay, so page 97 now. Okay. What did you call it? So I give you 2 plus 2 log 3x equals log 3y. Now, what rule of logs do you think I should use first? Well, I see this 2 here in front, so I'm going to take that up to the power here. And so I get 2 plus log 3x squared equals log 3y. Yep, you could do that. Although I think I'll take this to the right. I think it'll be easier for people. So I have now 2 equals log 3y minus log 3x squared. Now, what rule do I use next? Second rule. So I get 2 equals log 3y over x squared. And then we just need to finish by remembering our definition of log. So it means 3 to this power would equal this. So that means 3 to the power of 2 will equal what's inside there. Okay, well, what is 3 to the power of 2? It's 9, isn't it? And I can bring this up here. And that's part A finished. Okay, did you write that down? Yep, okay. Now, B part. Equal sign here. That's 21x minus 10. Now this one here looks familiar because it is. If we go back to the first one, you see here we have 2 plus 2 log 3x equals log 3y. And in this one here we have 2 plus 2 log 3x equals log 3, 21x minus 10. Now what they were hoping in the exam is that you'll recognize that this is exactly the same as the previous problem, except instead of y, what do I have instead? 21x minus 10. So in fact, when you try to solve this, you will go through exactly the same steps, except the y will be different. So what you're supposed to think to yourself is, Why bother going through the same steps again? Why don't I just jump to the answer at the end, except instead of y I have 21x minus 10.
Am I allowed to do that without the steps?
Oh yeah, that's actually what they were hoping you would do here. Yep. Of course, if you did the steps again, you would still get full marks, although you would have lost more of your life in the process. Okay, this one here is just a quadratic. So you got two answers here. X equals 5 over 3 or 2 over 3. Although we know that sometimes we have to check our answers. Well, we always have to check our answers, but sometimes some of them don't work. So if I go back to this equation, I can see because of this, I need x to be more than 0. Both are more than 0, yeah? Because of this one, I need 21x minus 10 to be more than 0. 21x minus 10 needs to be more than 0. That means 21x needs to be more than 10. That means x needs to be more than 10 over 21, which is about 0.5, isn't it? But I can see, looking at these, both of these are more than that. So in fact, both answers work here. So, well, that's it. We accept both of them. Got this written down? Yep. Okay. So it's A, B. Now time for part C. So in part C, I tell you V equals A, E, K, T. And I tell you that when T equals 5, V equals 70, and when T equals 8, V equals 130. And we have to find our K and our A. So, just like before, we have two unknowns, so we sub them in to get the A and the K. The only difference is this is a bit more difficult because one of the times is not 0. Previously, one of the times was 0. Okay, so we put the first one in, and I get 70 equals AE 5K, and I put the second one in, and I get 130 equals AE 8K. We have two equations and two unknowns, and this should remind you a little bit of the geometric worksheet. Any ideas how I could solve these two? Divide them. Which one do I put on top? The bigger power, yeah. So that's good, they cancel, and then you can subtract. So you get e power 3k equals 13 over 7. How do I cancel an e? With a log, so I get 3k equals log 13 over 7. So therefore k equals 1 over 3 log 13 over 7. Zero 0.206. But I still have to find the A now. How can I find the A? Sub in to this. So 130 over e power 8k, that's what the A equals. So 130 over e power 8k $24.95. So we have our answer. V equals A E K T. Although there's one thing they ask us to do here. That was only part 1. Yeah, see part 1. Although part 2 is not very difficult. They just want the value of V when t is 12. So I get V equals 24.95 e power 0.206, and when t is 12,
I've got 25, not 24.
depends how many decimal places you put in. It's okay though. See, if I just took this to the nearest whole number, I got 296, but it's 295.5.
I think you did this before.
We did. We did. It was one of
We
your
have,
tests. No, it was in one of your tests I gave you.
And we have extra math in the...
Maybe we did it in that.
Yeah.
Oh yeah, now I remember. Question? Yeah. That's okay. It depends how many decimal places you take for your K. In the exam, hey, listen. In the exam, it's not going to be a big deal because I think the way to do it now for sure is that there's only one question in the exam where they test you on decimal places and significant figures. So if you're just a little bit off on your other questions, it's okay. You won't lose any marks. But there is one question which I'll show you that tests your knowledge of decimal places and your accuracy. Okay? Right. Do you have this written down? Yes? Yes? Okay. Is that yes? Yes? Okay. So, number 2. So the question is, what values are the logarithms in this equation defined? So in other words, what values of x can you use? Well, in the first one, you need 4x minus 7 to be greater than 0. And no surprise here, we also need 2x minus 5 to be greater than 0. Both need to be positive. Yep. So we get x must be greater than 7 over 5, and x must be greater than 5 over 2. And if you want to put that on a number line, there's 5 over 2 there, that's about 2.5. And then 7 over 5 will be smaller than it, won't it? Yeah, it's not even, it's like 1 point and a bit, so 7 over 5 is there.
How did you get 7 over 5?
Yeah, how did I? 7 over 4. So this is 1.875 or something, and the other one's 2.5. Anyways, in this one here, you need x to be more than 7 over 4, And in this case here, you need x to be more than 5 over 2. So there's really only one way that you can have both satisfied, and what's that? If x is more than 5 over 2. Now I should actually say in the exam with the marking scheme, I don't know why they do this, I guess it's good news for you, but they give you full marks if you just get this much written down. Although for the rest of the question you need to have this result here. So just so you know, in the exam, in previous years anyways, it was enough just to write these 2 lines down because the question is 2 marks. But later in the question they'll probably ask you to solve it, which means you need to have this result anyways. So you might as well do it in this step here. So here this is to get full marks.
We have to do the line.
No, you don't have to, that's just to help you. But you can go straight from there to there if you can see it. This is extra. Okay, now you can see right away the next part is to solve this. 2a1 and now 2a2. Right, so what do you think I do first here to solve it? Yeah, bring the 2 up. So it's gone. So you have log something equals log something. And when you have this situation, what can you do? What can you do? If I have log A equals log B, what can I say? A equals B. No, if I have log A equals log B, then it must be because A equals B. Yeah, that they're the same. So in fact, then I can cancel the logs here, and I get 4x minus 7 equals 4x squared minus 20x plus 25. See, I just squared that out as well. So I get 4x squared minus 24x, and what am I doing? I'm taking things to the right, plus 32 equals 0. Well, actually I can divide by 4. X squared minus 6x plus 8 equals 0. That looks kind of nice. 4 and 2, x minus 4, x minus 2. So I get 2 answers, 2 or 4. But you can see x needs to be more than 2.5. So I can't actually use this answer. I have to reject this one. I can only use this answer, x equals 4.
Why did you reject the 2?
Because we need x to be more than 2.5 from the previous part. No, it's okay. You just look very suspicious there, Faisal. I thought you were using your phone. You were actually just oh, well, hang on, that's interesting. You have your phone on your notebook. Okay, yeah. No, I never seen somebody intensely read maths so much before. Like, okay, we got that one? Yes, next one now. So B part, it's another one of these model situations. Population equals AEKT. And you're told T is time, and at the beginning in the year 2000, so we'll call that T is 0, the population was 30,000. And then 10 years later, in the year 2010, the population was 36,000. Some people, and they're right if they want to, make t equals 2000 and t equals 2010. Although this just makes things much more, well, yeah, it makes it a good bit more difficult for you. In these situations, you can just make note here that t equals 0 represents the year 2000. Because, well, actually, they say it in the question there, if you read carefully, where t is the time in years from the year 2000, meaning that if t equals 1, it's 1 year from the year 2000, okay? So you were supposed to do this, although you'd still, I don't think, well, I don't know if I would take any marks off if you did it the other way, maybe not. But this is the easiest way to do it. It's nice when it's like this because we can see straight away what the A is when it happens like this. What's the A here? 30,000. So you already have the A. Now we can find the P. So we use the second point to find the P. So you get 36,000 equals A, E, K, T. So all those cancel. So you get 1.2 equals E10K. And then if you do log on both sides, you'll get 0.1823 equals 10K, if you put a log on both sides. And then that gives us the K. Divide by 10. So that answers the first part, what is the A and the K, not so bad. And then the second part is calculate the population in the year 2013. So the population in the year 2013 is A, E, K, T. And what's the T here? What's the T? 13. Okay. Got that written down? Yes? Okay. So number 3 now. First thing we need to do is simplify this. Oh, very good. Way ahead of me. Conjugate. So I multiplied the top and the bottom by okay. So on the top I'll get multiplying by 1 and then multiplying by 4 root 5. Now 4 root 5 times 3 root 5 is 60. And then when I multiply out the bottom, I'll get the middle term should cancel. That's the whole point of the conjugate. So you're just left with 2 times 2 is 4, and then minus 45. So you get 62 minus 11 root 5 all over minus 40. Sorry, what is something wrong? Yeah? What's 40? It's not 45, is it? Oh, sorry. I'm mixing up my 4s and 5s today. 41, thank you. Now, they actually want you to write it as a fraction, so we do 62 divided by 41, that doesn't simplify, so minus 62 over 41, and then 11 over 41 doesn't simplify as well. So you get minus 62 over 41 plus 11 over 41 root 5. Because he says in the question to write your answer in the form p plus q root 5, where p and q are fractions. So you can see p is this fraction, and then q is this fraction. Question? Okay. Continue? Yes? So now, B part is another simplifying. You have root x minus cube root x all over x squared. That equals, what power is square root? Half. And then cube root? A third, yeah. Now when I divide, what do I do to the powers? I subtract. So a half minus 2 is minus 1.5. And then a third minus 2 is minus 5 thirds. Is that right? And again, you're finished, because he says write this in the form of x power a minus x power b, where a and b are fractions. So a is minus 3 over 2, and then the b is minus 5 over 3. So that was a good one. Nice and short. That's 3 over 2 here, minus 3 over 2. This is an A and a B. C. They want you to calculate this without using your calculator. So we have to use all the rules of log. Firstly, can we do anything with the 24? Well, 3 squared is 9. 3 to the power of 4 is 27. So I'm not seeing anything with the 24. It's not 4 squared or 5 squared. You could say it's 12 times 2 or 4 times 3 times 2. Let's have a little right here. 24 is 12 times 2. But 12 is 4 times 3 times 2, so it's 2, 2, 3, 2. Looks like the best I can do with 24 is to say it's 2 cubed multiplied by 3. That's as good as it's going to get for 24, which may or may not be helpful, but I'll simplify it as much as I can. Now, what about the 1 over 9? Well, with the 1 over 9, I can say it's 9 power minus 1. Now that's looking promising, because what can I do here? Yeah, I can bring the minus 1 down. To make plus. And 9's looking good as well, because what can I say about 9? 3 squared. So this would be 8 log 3, 3. Yeah?
Are we just trying to simplify?
We are, yeah. There might be a typo in this because I don't see it becoming out a single number at the end, but we'll still simplify it as much as we can. So what's log 3 3? 1, so here's just 8. And here this is log 3 2 3 plus log 3 3, because I'm using the first rule to split these up. So log 3 3, 1. And then what can I do with the 3 here? Take it down. Like this. Okay. Right. Can I do anything to log 3 2? No. So I just have 3 log 3 2 plus 9. Okay. So if you want, you can rewrite the question to say simplify to the form A log 3 2 plus B, if you want to change that question. Here? I think what probably happened was that 24 should have been a 27, because if it was 27, then you could say it's 3 cubed. Yeah. Scroll down. So again, there is the A, and there is the B. Okay, last one now, D. Y equals 19 plus 11 e power minus 0.05 t. And I want you to find t when y is 25. So y is 25, and you need to find t. This isn't too bad. You take the 19 over to the left, and what have you got? 6 equals 11 e to the minus 0.05 t. And then what's next? Divide by, 11. So we get, if I want to use decimals here, 0.5454 equals e to the power of that. Now, how do I get rid of an e? With a log. So now I have minus 0.6061 equals minus 0.05 t. So therefore t will equal 12.12.